This lesson is going to be an introduction to algebra. Our learning objectives are to know the basic terminology of algebra, to be able to identify coefficients, terms, and constant terms within expressions, and finally, to be able to write expressions from word descriptions. As always, you shouldn't just be watching this video, but you should be writing notes down in the OneNote. Let's now begin with a question that we all should be able to answer. It says Atticus normally runs 10 kilometers a day, but today Atticus decides to run twice as far and then walks an additional 5 kilometers. Write an expression for the distance Atticus traveled today. I would like you to pause this video and see if you can answer this question. So how did you go with this question? Let's now answer it together. So we know that Atticus normally runs 10 kilometers a day, but today Atticus decides to run twice as far and then walks an additional 5 kilometers. Now we need to write an expression for the distance Atticus traveled today. So let's write down that we know that he normally runs 10 kilometers. So I'm going to write 10 down. But today he decides to run twice as far. So I'm going to times that by 2. So that's 20. And then we also know that he walks an additional 5 kilometers. So I want to add 5 to that 20. So I'm going to write plus 5. Now I could go 2 times 10 is 20 plus 5 is 25, but I'm actually going to leave it like this. Now before we move on, let's also appreciate the fact that I don't need to write brackets in here. And the reason why I don't need to is because according to my order of operations, BIDMAS, I'm going to do my multiplication first, then my addition. So those brackets would simply be unnecessary. So hopefully everyone feels pretty comfortable with writing an expression like this to describe what we see written here. So today we're going to be talking about algebra, and algebra is all about adding letters into our maths. So what we're going to do now is slightly change this question. So hopefully you can see what has now changed with this question. It now reads, Atticus normally runs n kilometers a day. But today, Atticus decides to run twice as far and then walks an additional 5 kilometers. Write an expression for the distance Atticus traveled today. So instead of dealing with the 10 kilometers, we now have a letter instead of a number. We have n. And it still wants us to write an expression. So let's just follow the same procedure that we just did. So I'm going to begin by writing down that n, because I know that he runs n kilometers a day. I then am going to times this n by 2, so 2 times n. And then I'm going to add my 5 kilometers that he has walked. So my answer now will be 2 times n plus 5. So the only thing that has really changed is I've put an n in that place which previously had a 10. But hopefully you can see why using this letter would be so advantageous for us. And the reason for it is because now Atticus could tell us what this n is, and we could immediately sub it in to find our result. So if we asked Atticus, well, how much do you normally run a day? And he tells me, well, I normally run 8 kilometers a day. Well, that means I could go 2 times 8 plus 5, which is 2 times 8 is 16 plus 5. So he runs 21 kilometers a day. But then he says, you know what, actually, I do actually only run 5 kilometers a day. I lied, it's only 5. And I go, well, no sweat, I can still figure out how much you run a day pretty easily. It's going to be 2 times 5 plus 5. 2 times 5 is 10 plus 5 is 15. So just like that, I can use my expression to immediately find how far Atticus is running. And let's remember, these are all kilometers. He's running 21 kilometers. And this too, this expression, you could put a kilometer on the end of this and say he's running 2 times n plus 5 kilometers. So hopefully you can appreciate why we like to use letters and why algebra can be so useful for us. So let's again just take a step back and recap what we did. So we know that he normally runs n kilometers a day. We then times 2 to that, and then we plussed 5. So we created an expression which describes this statement here. Let's now move on and learn some terminology, which is going to be crucial for your understanding of algebra. So the first word we're going to learn the definition of is the word expression, which you can see I've used here. So what is the definition of the word expression? Well, let's read it. An expression: numbers and letters combined with any mathematical operation. Addition, subtraction, multiplication, or division. So we would call this entire statement here, this 2n plus 5, this whole thing, we would call this an expression. So I want you to write that down in that blank space right there. That right there is an expression. Now the next word that we're going to learn is another word for letters. So in maths, we don't like to refer to them as letters. What we like to refer to them as is pronumerals. So a pronumeral is simply a letter that stands for a number. Now when that letter could represent any number, we refer to that as a variable. But for the time being, let's just write down the word pronumeral in this blank spot here. So everyone should be following along with me and writing in the word pronumeral. So that is a fancy word for letters that we use in math. So you should never say, oh, that's a letter. What you should rather say is that pronumeral. Now, in the same way that we have a fancy word for letters in mathematics, pronumerals, we also have a fancy word for the numbers found in front of my letters in maths. We call the numbers in front of the letters, we call them coefficients. So the number in front of a pronumeral. So the number in front of a pronumeral, so in this case 2, we call those coefficients. So again, I want you to grab your pen and write in the word coefficient in this box here, coefficient. So the coefficient is the number in front of the letter. Now, the next word that we have to learn has to do with the fact that this expression here has two parts to it. It has this 2n and this 5 as well. But in algebra, we don't call them parts. Rather, what we call them are terms. We call them terms. So a term is a single number or pronumeral, or numbers and pronumerals combined with multiplication or division. So in these blank spots right here, I want you to write the word term, term, term. So this 2n is a term, and this 5 is a term. Now this 2n, as you can see, it's a number combined together with a pronumeral, and it's combined together with a multiplication. So if you see down here, numbers and pronumerals combined with multiplication or division. So that is what this 2n is. But this term right here is just 5. And as you can notice here, my definition says a term can also be a single number. So a single number, that's just 5. And it could also be a single pronumeral. So if we were to add to our expression here, if we had plus a here, this a would be another term because it's just a single pronumeral by itself. But let's get rid of that. That's not actually there. The final word that we have to learn is a fancy word for a number by itself. So in algebra, if we have a number by itself, so in this case 5, what we call it is a constant. So a constant is a term that does not contain a pronumeral, a number on its own. So in other words, it's just a number on its own. So as you can see here, this is a term, 5 is a term, and because it does not have a pronumeral, or in other words, because it doesn't have a letter, we refer to it as a constant. So I'm going to write constant here. Now, the word constant is important. You can think of constant as something that does not change. We're always going to be adding 5 to this. My pronumeral, on the other hand, we can refer to that as a variable because the n could be any number, but my 5 is always going to be the same. It's always going to be 5. It's always going to be constant, and that's why we refer to it as a constant. So that is all the terminology that you need to know to be successful in algebra. Now, before we move on, I want to give you an important reminder about pronumerals, and that is that the choice of letter used is not significant mathematically. So that's really important that you appreciate the fact that the letter that we use for our pronumeral is not significant mathematically. So when deciding on which pronumeral to use, we usually just use X. But we could use any letter from the alphabet, A, B, C, X, Y, Z, etc. Sometimes when we're deciding on which pronumeral to use, we like to use a letter that relates to the thing we're referring to. So for instance, if I was describing someone's height, I might say that they are H centimeters tall, or for their weight, I might say that they weigh W kilograms, or I might refer to someone's age with the letter A. But it's important that you realize that mathematically, there's nothing important about any of these letters. We could use any of them to describe anything that we wanted to. And in later years of your secondary school maths careers, what you'll be actually using is Greek letters. So alpha, beta, theta, or sigma. So that will be later on in maths. And that's when maths becomes really, really fun, when you start to use Greek letters. But let's now go through an example which demonstrates how unimportant the letter that you use is. So here we have the height of a person. And what if you were asked to use a letter to represent the height of that person? So we need to find a pronumeral that we could use to represent the height of this person right here. Now you could say that they are X centimeters tall, or because we're talking about someone's height, you might say, well, it makes sense to use the letter H here. But that's really just kind of as a memory aid. There's nothing special about that H. We don't have to use it. We could have just as easily used X. Or you could say, I want to say T. Because why not? I want to say T. There's nothing important about the letter. Or if you really wanted to be fancy, you could even use a Greek letter. You could say that she is theta centimeters tall. But again, normally we use these Greek letters later on in our mathematical careers. Now, let's go through another example. If you were asked to use a pronumeral to represent the amount of lollies in a bag, you might say, well, there are X lollies in a bag. Or you could say that there are Y lollies. Or you could say, you know what, we're dealing with lollies and it starts with an L, so it would kind of make sense to refer to them as L lollies. But it really doesn't matter what pronumeral you use. It doesn't matter what letter you use. They have no significance mathematically. So I really want to make sure that everyone walks away knowing that the letter that we use to represent something has no significance mathematically. That's really important. Every year, there's someone who thinks that there's some hidden meaning behind the letter we're using. There isn't. Mathematically, they are insignificant. Let's now go through some example questions, and this is where I want you to pause the video and see if you can answer these 3 questions before you. So pause the video and give it a go. So how did you go with them? Well, let's now go through them together. So the first question asks me to state the individual terms in the expression 3a plus b plus 13c. Well, I know that a term refers to this and this and this. So I have 3 terms in this expression, and it wants me to state the individual terms. Well, I'm going to have 3a, I'm going to have b, and I'm also going to have 13c. 13c. So remember, a term could be a pronumeral by itself, it could be a number by itself, or it could be a number and a pronumeral either multiplied together or divided together. So these are my 3 terms for this expression. Let's now go to the next question, which is asking me to state the coefficient of each pronumeral in the expression. So we have 3a plus 13b plus c. So hopefully you know that the word coefficient is just referring to the number in front of my pronumeral. So for this one, my coefficient will be 3. For this one, my coefficient will be 13. And now we come to the one that will trick everyone. What is my coefficient of c? If you said 0, you are incorrect. The right answer is 1. The coefficient of my pronumeral c in this case is 1. And the reason for that is because there is an invisible 1 in front of c here. Now this is such an important point that I want to go through an example to make sure that you know this for sure. So you should have written all of this down, but now I want you to write down something a little extra. So this is what I want you to write down. If we have 3x, what does that mean? Well, what it means is that I have 3 x's. 3x just means I have 3 x's. So that would be equal to x plus x plus x. If I had 2x, well, that means I have 2 x's because it's just 2 times x. So that's just x plus x. Well, if I had 1x, what is that equal to? Well, it's just equal to 1 times x. It's just 1x. It's literally just x. So as you can see, if I have my pronumeral as x, I have an invisible coefficient in front of it of just 1 because 1x is the same as x. So for those who accidentally put a 0 as their coefficient to this answer, let's really reflect on what a 0 coefficient would mean. That would mean I have 0 x's, which means I have no x's. I have 0 x's because this is going to be 0 times x. And I know that 0 times any number is going to be 0. So that is all just to reiterate the point that when you have a pronumeral by itself, your coefficient is going to be 1 because there's going to be an invisible 1 in front of it. So let's now answer the last question, which is asking us give 3 examples of an expression with exactly 2 terms, one of which is a constant term. So if it's going to have 2 terms, well, my first term could be 2x, and then I'm going to plus a constant term, let that be 5. So notice here that I have 2 terms in my expression, 1 term, 2 terms, and my constant term. Remember that the word constant is just referring to a number by itself. So if I was to give another 2 examples, I could say 76a minus 27, because that 27 is just a number by itself, and I have 2 terms. Next, I could go 108y plus 3000. Because that 3000 is just a number by itself, it is a constant term, it has exactly 2 terms, one of which is a constant. I've satisfied all my requirements. So hopefully you understand everything here. Again, make sure that you're writing down notes with me so you can refer to them later on. Let's now go through a few more examples. So here we're being asked to write an expression for each of the following. So 5 more than k. So that's going to be simply k plus 5. Because it's 5 more than k. Now remember our commutative property of addition, which tells me that I could have also written this as 5 plus k. Because when it comes to addition, and I know it's addition because it says the word more, I know that the order doesn't matter. So either of these would be acceptable. So if you'd like, you could get your green pen and give them both a tick. So I'm going to give that a tick, and I'm going to give that a tick. So let's now look at the second question, which says 3 less than m. Now, as soon as I see the word less, I know I'm dealing with subtraction. And let's remember that the commutative law does not apply to subtraction, which means that the order does matter when we're dealing with subtraction. So we can't, like addition, just put them in any order. We have to make sure that I put my 3 and the m in the correct position here. So if it's 3 less than m, that means I'm starting with m and subtracting 3 from it. because this is saying 3 less than m minus 3. Now, where most people are going to make a mistake with this question is by simply following the structure or the order of the question itself. So what they're going to do is, well, 3 comes first, so they're going to write 3 down. Then they're going to see the word less, so they're going to subtract. And then m is the last thing in the question, so they're going to put m as the last position. Now, this is incorrect. And the reason why it's incorrect is because the order is incorrect. If we were to describe this in words, what this is saying, telling me, is that it is m less than 3, because I'm going 3 and subtracting m from it. So I want you to give that a big cross. But then I want you to come up to the first thing that we wrote here, m minus 3, and appreciate the fact that this is 3 less than m. So I want you to give this a big tick. Our final question says the sum of a and b. As soon as I see the word sum, I know I'm dealing with addition. And I know that I have the commutative law for addition, which tells me that the order doesn't matter. So I could write this as a plus b. Or, if I wanted to, I could write it as b plus a. So let me repeat myself. Because we have the commutative law of addition, I know that the order doesn't matter when it comes to addition. I can write a plus b or b plus a. So both of these would be a correct answer to this question. I now want you to pause the video and give these questions a go. So how did you go with these questions? Let's now answer them together. So we need to write an expression for each of the following. Double the value of x. So as soon as I see the word double, I know I'm going to be dealing with multiplication. So it's going to be 2 times x. Now remember, because I have the commutative law of multiplication, the order doesn't matter. So I could have written this as x times 2. But let's also remember that the best way to write something like this, where I have a multiplication, is not putting in the multiplication sign at all. So the best way to write it is 2x. And remember that your number is always going to come before your pronumeral. So this right here is the best way to write it, but technically these are all correct. Let's now move on to our second question, which is saying the product of C and D. The word product is just a fancy way of saying the result of multiplication. So this is simply going to be C times D. So C times D. And based on all of this, we know the better way to write that is actually CD without the multiplication sign. It's also important to remember that when we're timesing together two pronumerals, we normally like to put them in alphabetical order. So we want to put the C first, then the D. So that is the best way to write it. So you can give both of these a tick. Next, we want to find half of the value of z. So that is simply going to be z divided by 2. Now, another way you could also write this is if I want to half the value of something, that's the same as going a half times that value. And another way that we could write this, knowing that we don't have to put in that multiplication sign, is simply a half z. So these are 3 ways you could answer this question. I like this way, I like it this way. This way is okay, but remember, we don't like putting in that multiplication sign. Let's now answer some more questions, and we might actually move a bit quicker through these ones. Write an expression for each of the following without using the multiplication or division symbols. So p is halved, and then 4 is added. So that's going to be p divided by 2, because that's how I'm halving it. And then I need to add 4 to it, so plus 4. Now remember, you could also write this as 1 over 2p, because that's halving p as well, timesing it by 1/2, and then we're going to add 4 to it. So there are 2 options for the first question. Next, we have the sum of x and y is taken and then divided by 7. So I have x plus y, and then I'm going to divide that by 7. Now remember that I need to first take the sum of x and y and then divide by 7. Now according to my order of operations, BIDMAS, division comes before addition. So if I want to do this sum first, I'm going to have to put brackets around them. So that would be your correct answer. The sum of x and y then divided by 7. Now an even better way to write this, the way that I like to write it, would be x plus y. And then instead of putting that division symbol, you can go like that. That is, in my opinion, a prettier way to write it, but both of them are correct. Let's now answer the last question, which is saying the sum of x and 1/7 of y. Now, some of us might get a bit freaked out when they see 1/7 of y, but let's just kind of take a step back and think of something a bit simpler. If they were asking me to find 1/2 of y, well, 1/2 of y would be simply 1/2 times y, or I could also write that as y divided by 2. That would be 1/2 of y. So in the same way, when they're asking me for 1/7 of y, I could write that as 1/7 times y, or y divided by 7. So that's really not that difficult at all. So let me just rub all that out. That was just a little bit of an explanation of what 1/7 means. But let's remember what they're asking me is to find the sum of x and 1/7. So there are 2 ways you could write this. You could go x plus 1/7y, or if you wanted to, you could write it as x plus y over 7. Either of those would be correct. Now it's your turn, so I want you to pause the video and write an expression for the following without using the multiplication or division symbols. Good luck. Let's now answer these questions together, and we'll do this rather quickly. We have 5 is subtracted from k, and the result is tripled. So I'm dealing with subtraction, which means that the order is going to matter. 5 is subtracted from k, so that means I'm going to start with k, and then subtract 5 from it, and then I need to triple this, so that means I'm going to times it by 3. I'm going to put a 3 at the front. Remember, I don't want to put in that multiplication sign. This is a better way to write it. So this is the best way of representing this right here. Let's now go into the next one, which is 3 is subtracted from the product of P and Q. So once again, we're dealing with subtraction. So the order is going to matter. So it's 3 is subtracted from the product of P and Q. The word product here is just meaning the result of the multiplication of P and Q. So it's going to be P times Q. Remember, I'm not going to put in that multiplication sign. And then I'm going to subtract 3 from it. 3 is subtracted from the product of P and Q. So that is going to be your answer. Let's now answer the last one, which is 5 less than m is multiplied by 7. So this less right here tells me I'm dealing with subtraction, which means the order is going to matter. It's 5 less than m. So that means I'm going to start with m, and I'm going to subtract 5 from it, and then I need to multiply the answer of this by 7. So I'm going to put brackets around it and put a 7 here. So these are the 3 answers to these questions. Hopefully you got them all correct. If not, make sure you're writing down the correct answers. I want to go through one more question before you begin your homework, and I want you to have a go at this. So if you could pause the video and see if you could answer these questions right here. Give it a go. Let's now answer these questions together. So it tells us that Billy is paid $M per hour at his job. We first need to write an expression of how much Billy earns if he works 3 hours. I really hope that we're able to really quickly say, well, that's just going to be 3 times his hourly rate, which is M. So he's going to earn $3M. Now, if we want to take it a bit slower, we could say, all right, if he's going to work 1 hour, we know that he is going to earn $M. If he works 2 hours, well, that means that he's going to earn $M for the first hour, and then $M for the second hour, which is 2M altogether. So finally, if he's going to work 3 hours, that is the same as M plus M plus M. So an M for each hour, which is going to be 3M. But I really hope that we're able to do this really quickly by just going, it's just going to be 3 times his hourly rate. Let's now answer the second question, which is asking us to write an expression for Billy's hourly wage if he gets a pay rise of $2 per hour. So Billy must be doing something right at his job because they're giving him a pay rise. We now need to write this as an expression. So we know that originally he was getting paid $M per hour. So if he's now going to get paid $2 more per hour, we're simply going to plus 2 to it. So my answer is going to be M plus $2 per hour. Let's now answer this last question, which is asking us to write an expression if Billy now works for 3 hours on his increased wage. So his increased wage is M plus 2. And if he's going to work for 3 hours on it, we're going to multiply that by 3. Now, the reason why I've put brackets around M plus 2 is because I want to make sure that this 3 is timesing the result of it. So if I was to now break it down into this right here, how I could write it down is that it's going to be M plus 2 plus M plus 2 plus M plus 2. Now, hopefully you can see here, that's how much he's earning in his first hour, that's how much he's earning in his second hour, and that is how much he's earning in his third hour. If we were to plus this together now, and we're going to learn more about this in subsequent lessons when we talk about like terms, but what it's going to be is M plus M plus M, that's 3M. Then 2 plus 2 plus 2, that's going to be 6. So he's going to earn 3M plus 6, and that's the same as what we find up here. Now, if we wanted to delve a little deeper into this question, we could use our distributive rule. Now, remember our distributive rule tells us that we can go 3 times m plus 3 times 2. So let's now think of what that is going to be. 3 times m, that's 3m, and 3 times 2, that's plus 6. And hopefully you can see that that is the same as that. So all we've really done is just expanded out our brackets in a way to get his how much he's going to earn on his new hourly wage. So either of these would be correct. You could have written it like that. That would be the best way to answer it. Very efficient. But you could also write it like that as well if you wished. So you're using that distributive law that we learnt about. So let's now review what we've learned in this lesson. So this lesson was an introduction to algebra. And our learning objectives were to know the basic terminology of algebra. And hopefully you can give that a big tick. Next, to be able to identify coefficients, terms, and constant terms within expressions. Hopefully you're able to give that a tick as well. And finally, to be able to write expressions from word descriptions. And again, I hope that you're able to give that a tick. Hopefully this lesson was helpful to you. You now need to finish your homework for this topic. Good luck.